All right, let's go ahead and jump back in with the IVT stuff here for today. I'm on page 16, number 2. It says, consider the following. A function f of x is continuous on a closed interval. Additionally, f of 2 equals negative 1/4, and f of 4 equals 13. What must be true over the interval from 2 to 4? How do you know? So let's go ahead and start reviewing what we went over yesterday. Okay, the first thing that I'm always going to check is that we are continuous. And in fact, it tells us that f of x is continuous over the closed interval of, and boy, it should say 2 to 4 here. So let's go ahead and add that in there. So we are, continuous over a closed interval from 2 to 4. So f of x is continuous over 2 to 4. Now, if you remember back to the previous problems, we also needed to show that the outputs were, or that the initial output and the ending output bracketed a value that we wanted to see. So the input of 2 gives us an output of negative 1/4. That's the initial part of our interval. So from negative 1/4, it's going to be less than or equal to something, right? We don't know maybe what that is yet or what that represents. The input of 4 gives us, is our ending input, right? Gives us an output of 13. So that we are going to end up with an ending output of 13. So what must be true over the interval from 2 to 4 from this interval if we are continuous and we have an output of negative 1/4 to an output of 13? Well, what has to be true is that that f of x will achieve all the outputs between negative 1/4 and 13. Because we are continuous over the interval and our initial output of negative 1/4 and our ending output of 13, we're going to hit all of those outputs in between. And we know this by the intermediate value theorem, or IVT. All right, 3. Let's jump down and do at least part of 3 here. Or both parts, maybe. It says, determine whether the intermediate value theorem would guarantee a C value on the given interval for f of x equals x squared plus x over x minus 1, for f of c equals 6 over 5/2 to 4. So let's go ahead and, again, first thing I'm always going to check is I want to be able to see if I'm continuous over the interval that they give us. So from 5/2 to 4. Now, again, our function here has a denominator, which means that we're going to have a point of discontinuity. So when x minus 1 equals 0, we'll end up with a discontinuity, or at x equals 1. Now, does 1 fall in the interval from 5/2 to 4? Nope. So we can say that f of x is continuous over 5/2 to 4. That is the beginning part to show of IVT. Second part is to be able to check the outputs. So I need outputs 5/2 and outputs at 4, the beginning and the ending part of our interval. So f of, and I'm going to call it 2.5, and f of 4. I'm going to go ahead, or I have already gone ahead and computed those in a calculator. Okay, when I plugged 5/2 or 2.5 into my calculator, I got 5.833. And when I plugged 4 in, I got 6.667. If you need to, go ahead and take a moment to plug those in just to be sure. But we want to try and achieve an output of 6 when our initial output is 5.833 and our ending output is 6.667. So does 6 fall between those intervals? Yes, it does. So I'm going to show that 5.833 is less than the output that we want, 6. which is less than or equal to 6.667. So initial output, ending output, output we want falls between. We are continuous over that interval, so we can say therefore there exists, I guess we'll just say it this way, I see where f of c equals 6. So we're going to have an input value, we don't know what it is, where the output is going to be 6 because of our intermediate value theorem. So by IVT. Now, on some of these problems, they're actually going to ask you to find the C value. And for letter A here under number 3, that's exactly what they ask us to do. So we want to find the C value in which this occurs. Well, I want an input where the output is 6 of our function f of x. So take 6 and plug it into the output of our function. So I guess I'll do this over here. So 6 is going to equal x squared plus x over x minus 1. And now we get to go back to algebra class. Multiply x minus 1 over here. So 6 times x minus 1 equals x squared plus x. Let's see, distribution, 6x minus 6 equals x squared plus x. All right, I'm going to subtract 6x and add 6 in one fell swoop here. So I'm going to say that 0 equals x squared. X minus 6x will be minus 5x, and adding 6 will be plus 6. Now we want to factor, so let's go ahead and factor. Negative 5, positive 6. I think we want x minus 2 and x minus 3, right? Negative 2x and negative 3x will give me negative 5x. And negative 2 times negative 3 is positive 6. So the values that I want are x equals 2 and x equals 3. Now, do we want both values? Remember, our inputs go from 2.5 to 4. Even though we achieve the output of 6 twice for this function, the only one that we can show, the only one that fits our criteria for C, that goes between 2.5 or 5/2 and 4, is the value of 3. So the C value that we want here is C equals 3. 2 is outside of our interval.